Okay, let's talk about another measure of position that will help us actually determine outliers. This is called quartiles. So quartiles divide a data set into quarters. And so to think how this works, if we know a minimum and a maximum, we already know that a median splits our data set in half so that half the values are lower and half are higher. Quartiles then take each half and divide it in half again. So there'll be another marker here that we'll call Q1. And so that separates the lower half into two more halves. And on the top end, we'll have Q3, and that splits the top half into two halves. So we end up with our data set divided into a first quarter, second quarter, third quarter, and a fourth quarter. Now, the Q1 is a marker that tells us that 25% of our data is less than or equal to that value. The median is the point that tells us that 50% of our data is less than or equal to this value. And then Q3, you might guess, is the value that says 75% of the data is less than or equal to this value. And of course, the maximum, you can call that Q4, that would be 100% is less than or equal to this value. So another name for the median would be Q2, by the way. So let's say we have this data set 0, 10, 11, 13, and so forth up to 50. And we want to find the quartiles. So first, I'm going to find the median, the value that separates the lower half from the top half. So let's see, how many values do I have? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values. So this is an odd number. You may remember that if we look in position n plus 1 over 2, we can locate our median. So this would be 14 over 2, which is 7. So look in position 7. This is our median, which we use a capital N. So there are 6 values below that and 6 values above that. So let's find Q1. So we're going to look in this lower half and just find the median for those 6 values. So we have an even number, so we're going to have to take an average, and we need to find the average of these two values. So 13 plus 11, that's 24 over 2 is 12. Obviously 12 is right in between 11 and 13. So this is Q1. Q2, the median is 27. And then we can look in the top half and do the same thing. Here are the values that are in the middle. We need to average those. And if I take 42 and 36, I get 78. And half of that is 39. So Q1 is, I'll write this over here again, this is 12. Q2, our median, is 27. And Q3 is 39. So that means that 25% of our data is less than or equal to 12, 50% of the data is less than or equal to 27, and 75% of the data are less than or equal to 39. So next, let's talk about IQR, which stands for inner quartile range. This is the range for the middle 50% of our data. So in this case, I want the middle 50%, not the entire range, which is the maximum minus the minimum, but just the range for the values that are in the middle. So to find this, we simply take Q3 and subtract Q1. So in this data set, I would take 39 minus 12. So 9 minus 2 is 7, and 3 minus 1 is 2. So the IQR is 27. So for this data set, the range for the middle 50% of data is 27 and whatever the units would be, 27 inches or 27 miles. The IQR can be used to help us determine if there are outliers. So outliers are values that are in the extreme of our data set. They are unusually large or unusually small. And so we would like a way to quantify this. So the way that this works is we find a lower fence and an upper fence. And once we set those fences, anything outside will be considered an outlier. So the way that this works for the lower fence is we'll take Q1 and subtract 1.5 of the IQR. So for instance, in this case, I would take Q1, which is 12, and subtract 1.5 times 27. So 1.5 times 27 is 40.5. And when I subtract that from 12, I get negative 28.5. So anything less than negative 28.5 would be an outlier. Well, our lowest value here was 0, so there are no outliers on the low end. For an upper fence, I'll take the Q3 and add 1.5 of the IQR. So that would be 39 plus 1.5 times 27. So 1.5 times 27, we already know that's 40.5, and add that to 39, and we'll get 79.5. So anything greater than this would be an outlier. Our highest value was 50, so there are no outliers on the high end either. If this had been 150, then that would be greater than this, beyond this fence, outside our fence, and we would consider it an outlier. So let's look at an example. These are the weekly incomes for 50 random recent college graduates. And so there are 50 of them, and let's look at how we can find then the quartiles and also IQR and see if there are any outliers. So I have 50 items here, and so the first thing I want to do is find the median. In other words, that is the same as Q2. So I have 50 items. That's an even number of things. So I know that I'm going to have to, I wanted to separate my data set into 25 and 25. So there are 10 things in each of these. So this will be item 20, 21, 22, 23, 24, 25. So here's where I'm going to separate the data into the lower 25 and the upper 25. So I need to take an average of these two values, 289 and 281. So I'll add those together and divide by 2. 289 and 281 divided by 2. That's 285. And then I want to look at the lower half and find the median just in this lower half. So since I had an even number of values and was able to split my data in half and didn't use one of the values to do so, I'm going to look just in, let's see if I can cover this up like this, just among those 25 values. So this time, since I have an odd number, I'm going to have to be able to find a value that's right in the middle. So if I take 25, add 1, that'd be 26 over 2 in position 13. So this is 10, 11, 12, 13. So Q1 is 13. And now I want to find the 13th value in the upper half. So that will be in these values. I kind of messed up in ordering my data here, but I think I can make up for it. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And you'll notice that there are 12 values above that and 12 values below it. Sure enough, that works for Q3. It's 479. So I have Q1, Q2, and Q3. So next let's find the IQR. That's Q3 minus Q1. In other words, 479 minus 13. So 9 minus 3 is 6, 7 minus 1 is 6, and 4. So that's the IQR. To find my lower fence, I take Q1 and subtract 1.5 times the IQR. So Q1 was 13. I'll subtract 1.5 times 466. So 13 minus 1.5 times 466 is negative 686. So there's the lower fence. And next, let's get the upper fence. That's Q3 plus. So for the lower fence, you're subtracting. For the upper fence, you're adding. But in both cases, it's 1.5 times the IQR. Q3 was 479. And we take 1.5 times 466. So 479 plus 1.5 times 466. This is 1178. So I have an upper fence of 1178. So if I have any values that are less than negative 686 or more than 1178, those would be outliers. So going back to the original data, there are no negative values. These are weekly salaries, so there aren't going to be any values on the low end. But over here on the high end, I have this value of 1277. And sure enough, that is more than this value, which is my upper fence. So 12,777 for a weekly salary is an outlier. And because I have units, I'm going to put them there. Those are in dollars. So there you have an example of how we use quartiles, in particular how we use the interquartile range to find outliers. Hope that helps.